Hello 108 class, Mr. McHugh here with you on section 9.3 as we continue our journey on page 3, solving equations that have got the quadratic formula in them here, and we're going to look at example 4 and we're going to deal with ones that have got the radical in it. Okay, everybody knows what the radical sign looks like. We're going to deal with square root ones, so the index will automatically be a 2 and we don't write it, as you all know. And back in chapter 8 we've worked with some of these problems before, so this is not necessarily brand new, but it's a good refresher for everybody here. And so I look at example A and I notice x equals the square root of 6x minus 8, and they go, oh, saw that equation, isolate the x, and it's on two places, one's underneath the radical. I go, ooh, I got to deal with that radical. And then if you go back and look at the sections there, and this is where I was thinking, use your hand notes you've been working on. You should have some of them, or my class notes, you should have listed the 4 or 5 step process, and one of the first ones is to clear the radical so it's all by itself on one side. So we've already done that on this problem, example A. Next, what do we do to negate or get rid of radicals? We do what to both sides of the equation? Square it. Okay, so we square, because when you square, it negates the square root, and whatever is left and underneath the radicand, I put an R there for radicand, drops down. Okay, so here we go. Take the left side, square it. What do you get? X squared. Take the right side, square it. What happens? The radicand drops down, and now you've got x squared equals 6x minus 8. Well, that's not so bad. What should you do? Okay, I'm hoping you remember the standard form of the equation is to move all three terms over to the left, because you want a positive ax squared plus bx plus c set equal to 0. So minus 6x on both sides. I'll stick it over here. Plus 8 on both sides. What are you left with? X squared minus 6x plus 8 equals a big fat 0. Okay, now you got your options. Now I don't know how many of you guys would use the quadratic formula and plow through substituting a, b, and c. Many of you will use what you see here. I would always try to do reverse FOIL or FLOY and see if you can factor it. And you could tell this one's not too bad. The numbers are pretty easy. They don't beat you up too bad here. Factors of 8, negative 4, negative 2, add them up equals negative 6. Make sure you unlock the safe. Don't forget that. Now what do you do with each parentheses? You know by the zero factor formula. Set them equal to 0. Here we go. Solve for x, add 4, minus, add 2 to each side, and bam, x equals 2. Excuse me, x equals 4, x equals 2. What do my little check marks tell you? If you substitute those back into the equation, take value for these, stick them back into here and here, work it out, you'll get left side equals right side, and bam, those are your solutions of 2, 4. Okie doke, not bad, we're cruising. I look at example B and I'm like, oh, okay, I don't know. It got an x and plus the square root of x. I'm like, ooh, how am I going to tackle this one? And I remember, don't care for radicals, get it isolated on one side, so therefore you got a minus x on both sides of the equation. Square root of x equals 6 minus x. Okay, I've done that, and I'm like, still got to get rid of that radical, so take both sides of the equation and square them. Okay, both sides of the equations are squared. It looks like I missed that on my notes here now that I'm doing this with you guys. And here we go. Sorry, just making some notes here. What are you left with? Oh, wait, that's a mistake on my part. Got it. What am I doing? Square both sides of the equation. So you're left with the quantity 6 minus x squared. That's a key. Make sure you put those parentheses on there. Okay, you got the radicand drops down. There's the x equals. Now, can you do this? This is a binomial squared. We've done lots of these back at chapter 7, I think it was. You could use FOIL. 6 minus x times itself. 6 minus x would trigger off FOIL. Okay, but what you're going to realize, the shortcut is it's binomial perfect square trinomial, so take the first term and square it. Multiply the first term times the second term, which would be a negative 6x, and double it. That's where the negative 12x comes. Take the second term and square it, so negative x squared is x squared. Okay, you will get this result. the shortcut way, special products rule, or using FOIL, first out or inner last. Okay, now you got here, you've seen it before. So what I like about algebra, once you've gone through a series of steps, you get to a point, you're like, okay, there was the new twist up at the beginning. From here on down, you got a quadratic. I would try to factor it, so it's a, oh, excuse me, I skipped a step. Got to set it equal to 0, so I minus x on both sides. Watch the details. Here's 0, add them up, 36. Negative 12x minus 1x would be a negative 13x squared plus x squared. Positive x squared is on the right hand side, leave it there. Use reverse FOIL, factor them. I got x squared, I'm looking at 36, I'm trying negative 4, negative 9. Multiply, give me a positive 36. Add up the O and the I. Good news, you get negative 13x, you're on track. Now, therefore, you're going to take your zero factor property. It says take each parenthesis, set them equal to 0. So there you go. Solve for x. X equals 4, x equals 9. This one checks out, and look at this. When you put 9 back in, it will not work out. Therefore, it's not a solution. The only one you got is 4. Okay, you got to do that. I know that's a pain. That's because of the erroneous solutions can't appear whenever you are squaring both sides of the equation. Okay, so look, we've done pretty good here now. This bottom of this page, we're going to start objective number 4. Let me talk about it here for a minute or two. Solving quadratic equations using the substitution method. Okay, so this idea here is you could take an expression and substitute it out by using the letter U. Now, theoretically you can use any letter you want, but the book uses U, and I'll stick with it because that's just kind of a pseudo convention. And if you could mold or shape the form of a quadratic where U is an expression, and you're going to see some examples on the next page, and if U is an expression, and the key to doing these is the middle term, I'm going to show this here in a minute. Whatever the middle term is, that's going to be the U, and then you're going to square it. If you match this where A, B, and C are your constants, and you've got U squared plus U, again, it's a pattern matching, all sides equal to 0, then you could solve for it. Okay, so I'm going to talk about that on the next page. Without an example, it's kind of hard to give you some concrete work on it. But you want to see this. I do know this is on the final. It'll be on the test too. So I remember seeing this on the final. So you want to make sure you get that substitution technique. And I got some tips to help you out. Okay, Ms. McHugh, we are going to sign off here on page 3. This page, section chapter 9 gets a little longer, so we've still got a couple more pages to go, but hang in there. Page 4, we'll go ahead and do that substitution method. Okay, till then, take care. Bye.